Today in this video I am going to explain a nice problem, Fox and names. It is division to Codeforces around 290. What the problem state that you are given a list of strings and actually they are sorted. You have to assume that these strings are sorted, and as you see that if the string list is sorted, it must come the first. But this is the catch. The problem is saying that you should reconstruct the alphabetical order to make the list a valid sorted list. Like, it is not actually a valid sorted list, so change the alphabetical order. That you know that we start our alphabetical order with A, but as we have to make this list a valid sorted list, we have to start with B, C, D, E and up to this. Then it is the problem. And if you can't make the reshuffle the alphabets to make the list a valid sorted list, then print impossible. This is a nice problem. Let's first understand how we check the strings which is lexicographically smallest and which is lexicographically bigger. Like, first we just say check that the ink is too much, like A, B, C, D and A, B, X, Y. We just check character by character until we find a difference. Here A is A, B is equal to B and C is not is equal to X, so we find a difference here. And whenever we find a difference here, we check which alphabet comes first in the valid alphabetical order. You know C must come before X, so it is lexicographically bigger than the first string. So actually when we compare strings, actually we have to just compare one character. This is a nice hint. Just we care about one character. There can be another case as stated in the problem. There would be another say A, B, C, D and the another string is A, B, C, D, E. Then it is a valid lexicographically sorted string, that it comes before this, because there is same A, B, B, C, C, D, D and there is nothing. It is bigger length, so it is valid. But if the case is like that, if anything comes in the test case like that A, B, C, D, E and it is A, B, C, D, then it is you can never make a valid alphabetical order to make this a valid sorted array. It can never be lexicographically smaller than this, as it has bigger length and the characters are similar to end of the smaller string, and it has more characters here. So if we find anything like this, we will print impossible. We can make this a valid sorted list. So what we found one case that is impossible, but is there anything that make impossible? Let's understand this. This is perfect, nice. As I give you intuition that we just need to check one character. Actual fact depends on only one character, so actually we will use Topological Sort to solve this problem. What we will do, we will construct a directed graph. Like, first compare these two strings. We found dissimilarities here, then as the list is sorted, then P must come before E. We are it's not true, but we are reshuffling the order to make the list a valid sorted list. So P must come before E. Then we will make a edge between P to E, a directed edge P to E. Then there is a difference is G and G to E. There will be a edge between G to E. You know, topological sort gives us a list, gives us an order where P will come before E and G will come before N. That's what we want now. And I show you an impossible case, and there is an impossible case here that when we can't get a toposort from a directed graph, when it is a cyclic graph. If it is a cyclic graph, we cannot make the we can have a topological sorted order from the graph. So it's also an impossible case. If we found, after making the graph, if we found a cycle, then it's a impossible case. So this is the main problem problem solving approach. We will use toposort here. Let's go to code. First we will take the string list and then create a graph on I just tell how I use the code. I don't use a character graph, I use an integer graph. Like if there is an edge between A to C, I just convert it to 0 to 2. Then it is easier to compute for me. And when there was an impossible case which is like that, the lesser is smaller, string has bigger length, I just return -2 to indicate that. And there was a case that we don't need to compare, as the lexicographical is smaller, string is length is smaller, and lexicographical bigger, string has bigger length. Then I just print -1, that we don't need to have any comparison here. And now then I get node from, and comparing just adjacent string. I just comparing tourist with Peter with WZMZ, this just adjacent ones string. Therefore I is equal to I n minus 1, comparing just v of I and v of I plus 1. Get node will give me, if the first size is less than the difference is between the strings, then I just corresponding integer for that character. And if the size is bigger, then I am printing getting -2 to state that it is an impossible case. And if no need comparison, I am sending -1. Like here, if p dot first is less than 0, then if -2, then okay is false, and if -1, then I don't need to have any comparison, and otherwise I am creating the graph. Then I am checking is there any cycle or not, as we will use toposort here. And this is a normal easy DFS cycle checking code for directed graph, and this is the toposort code. And then if there is cycle, and then if that is not okay and it is impossible, then I use a stack to keep the topological sorted list, and then use the toposort and then print it. And as I stored integer in the graph, then I convert the integer into the character and print it. This is the solution of the problem.